Welcome to the deep dive.
Glad to be here.
So today we're looking at some sources that connect a couple of different areas.
Yeah, things you might not think go together.
Exactly. Mathematics, specifically integration, that part of calculus.
Can be a tough one.
Right. And we're linking it to something, well, pretty down to earth.
Very practical, actually.
And our mission, as always, is to find the single most important insight here for you.
Okay, so often you see integration just as like textbook problems, right? Finding areas under curves.
Purely abstract exercises.
Exactly. But what these sources show is a really tangible, specific application. It brings the math to life, you could say.
Okay, so let's drill down. What's the core finding? The sources draw a direct line between integration.
Which is basically summing up lots of tiny changing bits to get a whole.
Right, between that concept and a very specific real-world use.
Yes, the source points directly to using integration to figure out the total energy expenditure of animals.
Animals, wait, like farm animals? Livestock.
Precisely, yeah. But the source is quite specific about the setting.
Okay.
It's about animals in rotational grazing systems, on farmland.
Ah, okay. So I'm picturing like a field split into paddocks. And the animals, maybe cows or sheep,
Could be, yeah.
they get moved from one section to another regularly.
That's the system. And the source says integration is the tool for calculating the total energy those animals use up while they're in that kind of setup.
Okay, but why integration specifically? Why is that the right mathematical tool here?
Well, think about it. An animal's energy use isn't just a flat number.
Right?
It changes constantly.
Sure, depending on if they're eating, walking, resting.
Exactly. It fluctuates. So integration lets you capture that changing rate of energy use, like moment by moment.
Okay.
And then it adds all those tiny moments up over the whole time the animal is grazing in one spot or moving to the next.
So you get a really accurate total, not just an average guess.
That's the idea.
Yeah.
A precise total energy consumed or expended.
Okay, so the source highlights this calculation. But then the question is, what do you do with that number? Does the source say?
It does. It suggests this figure, the total energy expenditure, is actually really useful for managing these grazing systems.
How so?
Well, knowing the actual energy burn helps farmers make better decisions, like how long to keep animals in one paddock.
Optimizing the rotation.
Right, or figuring out their nutritional needs more accurately, based on real energy output.
Not just standard tables.
Exactly. It could even help monitor, animal health or how efficiently they're converting feed. It's practical farm data.
So it's definitely not just math for math's sake.
Not at all.
Oh.
It has direct implications for managing the farm, maybe even for sustainability.
Okay, this is where it gets relevant for you listening, especially if you're like in the middle of learning calculus right now. This example, this specific use case, really shows that integration isn't just some abstract concept about areas.
It's a tool, a powerful one.
Yeah, a tool you can use to analyze and even optimize complex real-world systems, living systems even.
Like tracking how efficiently livestock turn grass into, energy or biomass. It lifts the math off the page.
It shows how these mathematical ideas become a language, really, for understanding biology, agriculture, things you might not connect with calculus usually.
Absolutely. Provides a quantitative way to look at these processes.
So wrapping this up for you, the key insight from our deep dive today, pulled from these sources, integration finds a very concrete job calculating total animal energy use in rotational grazing.
A specific link. Calculus to practical farming. It gives farmers actionable data.
Right. Data to manage things better. It's a direct bridge from your studies to the real world.
And maybe thinking about this specific, maybe slightly unexpected example makes you wonder, doesn't it?
Wonder what?
Where else? Where else are these math concepts you're learning being used in ways that aren't immediately obvious?
That's a great thought to end on. Keep an eye out, in science, tech, economics, maybe even simpler everyday things.
Where is the math hiding in plain sight?
See if you can spot it. Thanks for joining our deep dive.